Dear students, Physics Practical ਦੀ ਇਸ ਇੰਟਰਸਟਿੰਗ ਕਲਾਸ ਵਿੱਚ ਤੁਹਾਡਾ ਸਾਰਿਆਂ ਦਾ ਸਵਾਗਤ ਹੈ। ਇਹਨਾਂ ਆਡੀਓ ਵਿਜ਼ੂਅਲ ਕਲਾਸਿਸ ਰਾਹੀਂ ਅਸੀਂ ਤੁਹਾਨੂੰ ਐਕਸਪੈਰੀਮੈਂਟਸ ਕਰਨ ਦਾ ਕਰੈਕਟ ਵੇ ਸਿਖਾਵਾਂਗੇ। ਅੱਜ ਦੀ ਇਸ ਕਲਾਸ ਵਿੱਚ ਅਸੀਂ ਤੁਹਾਨੂੰ ਦੋ ਐਕਸਪੈਰੀਮੈਂਟਸ ਸਿਖਾਣੇ ਹਨ, ਜਿਨ੍ਹਾਂ ਵਿੱਚੋਂ ਫਰਸਟ ਇਜ਼ to find the focal length of a convex mirror using a convex lens, and second is to find the focal length of a concave mirror by UV method using two needles. ਪਹਿਲਾਂ ਅਸੀਂ concave mirrors ਅਤੇ convex mirrors ਦੇ focus ਅਤੇ focal length ਦੀਆਂ definitions ਰਿਵਾਈਜ਼ ਕਰ ਲੈਂਦੇ ਹਾਂ। ਫੋਕਸ ਨੂੰ ਪ੍ਰਿੰਸੀਪਲ ਫੋਕਸ ਵੀ ਕਿਹਾ ਜਾਂਦਾ ਹੈ ਅਤੇ ਇਸ ਨੂੰ ਕੈਪੀਟਲ F ਨਾਲ ਰਿਪਰੈਜ਼ੈਂਟ ਕੀਤਾ ਜਾਂਦਾ ਹੈ। ਪ੍ਰਿੰਸੀਪਲ ਫੋਕਸ represented by capital F of a spherical mirror is a point on the principal axis of the mirror at which rays incident on the mirror in a direction parallel to the principal axis actually meet or appear to diverge after reflection from the mirror. ਆਓ ਪਹਿਲਾਂ ਤੁਹਾਨੂੰ concave mirror ਅਤੇ convex mirror ਦੀ definitions ਇੱਕ audio visual ਰਾਹੀਂ ਦਿਖਾਈਏ। ਇਹਨਾਂ ਨਾਲ ਹੀ ਤੁਹਾਨੂੰ focal length ਵੀ clear ਹੋ ਜਾਵੇਗੀ।
For a concave mirror, when some rays of light coming from infinity and parallel to each other are incident on it, after reflection they meet at a point on the principal axis in front of the mirror. This point is the focus or principal focus of the concave mirror. It is denoted by capital F. Since the reflected rays of light actually meet at this point, capital F is considered as a real point. For a convex mirror, when some rays of light coming from infinity and parallel to each other are incident on it, after reflection they diverge and appear to come from a point on the principal axis behind the mirror. This point is the focus or principal focus of the convex mirror. Since the reflected rays of light do not actually meet at this point, F is considered as a virtual point, where from the rays appear to diverge after reflection. The distance of principal focus F from the pole P of the spherical mirror is called focal length of the mirror and is denoted by small f. PF is equal to small f. विद्यार्थियों, ਅੱਜ ਦੇ ਐਕਸਪੈਰੀਮੈਂਟ ਦਾ ਆਬਜੈਕਟਿਵ ਹੈ to find the focal length of a convex mirror using a convex lens. For conducting this experiment, the requirements of the apparatus are an optical bench with 2 pins, a meter scale, a needle, a convex lens, a convex mirror, a lens holder, a mirror holder, and 2 uprights. Let me now explain the ray diagram of the setup of this experiment. A convex lens is placed in the front of a convex mirror, such that they have a common principal axis. An object pin is placed in front of the convex lens. The rays of light starting from the object pass through the lens, converge slightly, and reach the mirror. The position of the mirror is so adjusted that after successive reflection and refraction, the image formed exactly above the object. Let's see the situation after removing the convex mirror. The position of the object is such that a real and inverted image is formed at the center of curvature of the lens. We will need to use a formula for calculation. This is nothing but the relation between radius of curvature of the mirror r and focal length f for a convex mirror. That is, f equal to r by 2.
The theory behind this says a convex mirror always forms a virtual image, and therefore its focal length cannot be found directly. To find the focal length, indirect method is used. An auxiliary convex lens whose rough focal length has been found is placed between the convex mirror M and the object needle O. The object needle is placed at a distance 1.5 times the rough focal length of convex lens, and the position of convex mirror behind the convex lens is so adjusted that a real and inverted image of object needle is formed at O itself. It will happen only if the rays of light starting from the object O strike the convex mirror normally after the refraction through the convex lens. In the absence of the convex mirror, these rays would have met at the center of curvature of the mirror. The focal length of a convex mirror is half of the radius of curvature. ਚਲੋ ਹੁਣ ਇਸ ਐਕਸਪੈਰੀਮੈਂਟ ਦਾ procedure ਵੇਖੀਏ.
To start the procedure, we will begin with finding the index correction first. Measure the length of the pin with the help of the meter scale. Then, fix the distance between the convex mirror and the tip of the upright exactly equal to the length of the pin. Finally, note down the distance between the central lines of their bases. The actual length of the needle X is 8.6 centimeter. On the other hand, the observed length of the needle Y is 8.7 centimeter. Therefore, the index correction X minus Y is equal to minus 0.1 centimeter. Now, let's see how to go further with the procedure. Determine the rough focal length of the convex lens. Locate a distant and illuminated object opposite a wall that can be treated as a screen. Now, focusing at this distant object, adjust the position of the lens to produce the smallest and sharpest possible image by moving the lens to and fro. Measure the distance between the mirror and the image using a meter scale. Then, clamp the lens holder with the convex lens at 50 centimeter mark on the optical bench. Fix this upright in this position throughout the experiment. Next, take a thin optical needle and mount it on an upright and place it at a distance of 1.5 times the focal length of the convex lens towards the left of the lens. Now, mount the convex mirror on another upright and place it near the lens towards the right of the lens, as shown here. Keeping the left eye closed, keep your right eye approximately 30 cm away from the object needle. From this distance, observe the inverted image of the object needle formed by reflection from the convex mirror. Let the tips of the object needle and the image of the object needle coincide. Remove the parallax by moving the convex mirror back and forth. You may have to make this adjustment over a number of times. At initial stages, parallax removing may require a lot of practice and time. Finally, as you can see here on the screen, this is how the condition of the tips of the object needle and the image of the object needle be when you actually remove the parallax. At this point of time, note the position of the upright holding the needle. Also note and record the positions of convex mirror upright and the convex lens upright. Remove the convex mirror and place another upright with a thick needle. Now, again remove the parallax between the image needle and the image of object needle on the other side of the lens. Let me caution you once more. You are not to disturb the position of lens or the object needle while adjusting the position of the image needle. Note and record the position of the image needle. Repeat for different needles and take at least 3 different sets of readings. Find the index correction to be applied to R, the radius of curvature. And now, it is the turn of getting to learn the observations writing. The observation for index correction that we took initially is to be written as shown here. Then, state the rough focal length of the convex lens in centimeter. The observation table is to be made like this. See it carefully and keep the headings of the columns in mind. You can write brief hints for use later on. The various observations are going to be like this. Then, let's see how we make the calculations. First of all, calculate the mean R using the values of R from the last column of the observation table. Then, divide the value of mean R by 2 to get the focal length of the convex mirror. The result is to be written as the focal length of the given convex mirror is 19.4 centimeter for the given mirror in this case. As every other experiment, this one also has some precautions to be followed. Have a look at them. The uprights should be vertical. A spirit level can be used to make the optical bench horizontal. The object needle should be placed at a distance more than the rough focal length of the lens, so that only a real and inverted image is produced. Tips of object needle and image needle should be at the same height and should correspond with the center of the lens and pole of the mirror. Keep your eye at least 30 centimeter away from the image needle to view the image clearly. A parallax should be removed tip to tip. Index correction should be applied to the radius of curvature R of the mirror. The most likely sources of error are the uprights may not be vertical, the parallax removed may not be perfect.
Dear students, it was mentioned in the beginning of this class that we have learned 2 experiments today. Let's take over with the second experiment lined up for today. In this experiment, we will determine the focal length of a concave mirror by UV method using 2 needles. You could be wondering what this UV method is. It is nothing but using the mathematical relation between the object distance u and the image distance v for a concave mirror. And now let's learn the experiment.
The objective of the experiment is to find the focal length of a concave mirror by UV method using 2 needles. Let us recall a concave mirror and understand the ray diagram that is to play its role in the desired situation. If an object is placed between the focus and center of curvature, the rays of light starting from it get reflected from the mirror and meet at a point beyond C, below the principal axis. Hence, a real inverted and enlarged image is formed there. Apparatus: an optical bench along with 3 uprights, 1 mirror holder, 2 needles, concave mirror, a knitting needle, and a meter scale. Theory: the relation between the object distance u, the image distance v, and the focal length f of a concave mirror is given as 1 over f is equal to 1 over u plus 1 over v, or f is equal to u into v upon u plus v. In the case of concave mirror, for real image, both u and v are negative as per new Cartesian sign convention. The focal length f is also negative. So, we will take up the procedure now. First of all, you are supposed to find the rough or the approximate focal length of the given concave mirror. See how it can be done. Obtain a clear and distinct image of some far-off object on a white paper with the given concave mirror. Adjust the distance between the white paper and the mirror so that a sharp image is focused on the paper. Measure the distance between the white paper and mirror with a meter scale. This distance is the approximate focal length of the mirror. Then find the index correction. Here, the length of the pin is measured with the meter scale. Then, the distance between the convex mirror and the tip of the upright is fixed exactly equal to the length of the pin. Finally, the distance between the central lines of their bases is noted down. The actual length of the needle X is 8.6 cm. On the other hand, the observed length of the needle Y is 8.7 cm. Therefore, the index correction X minus Y is equal to minus 0.1 cm. Then hold the concave mirror in the clamp of one of the 3 uprights. Mount it in the clamp holder in such a way that the principal axis of the mirror is horizontal and parallel to the length of the optical bench. For this, shift the upright carrying the mirror near one end of the optical bench and look into the mirror, keeping your eye vertically above the bed of the optical bench. Now, turn the mirror slowly in such a way that the image of your eye is obtained at the center of the mirror. This ensures the principal axis of mirror being parallel to the length of the bed. Further, mount the two needles on the uprights and adjust their heights in such a way that the tips of the two needles and the pole, that is, the center of the mirror, lie in the same straight line, parallel to the length of the optical bench. After this adjustment, the tips of needles will be at the same height as the pole of the mirror. Make a distinction between the object needle and the image needle by putting some distinguishable marks on them. To do this, a paper flag may be fixed on one of the needles, say on the object needle O. Mark the position of a point which is at a distance equal to the approximate focal length from the pole P of the mirror. Shift the object needle towards the pole P of the mirror to a position that lies beyond the focus F, but remains between F and C, the center of curvature of the mirror. You can see the real and inverted image in the mirror by closing your one eye and keeping the other eye along the optical bench at the height of the pole of the mirror. Now mount the second needle on the upright and shift this needle to the first position of the image of the object needle. Remove the parallax between this second needle and the first image of the object needle. In the position of no parallax, the second needle locates the position of the image of the object needle. For this very reason, the second needle is termed as the image needle. Note and record the positions of the object needle, the image needle, and the mirror on the bench scale. Repeat all these steps for 4 different positions of object needle, that is, for 5 different values of U, and record in your notebook under the heading Observations. Rough focal length of the concave mirror in centimeter. The actual length of the needle X is 8.6 centimeter. On the other hand, observed length of the needle Y is 8.7 centimeter. Therefore, the index correction X minus Y is equal to minus 0.1 centimeter. This is how you are expected to present the observation table. Give a careful watch. After entering the positions of the object needle, image needle, and the mirror, calculate the respective object distances U and the image distances V for each set of readings, and then calculate their corresponding reciprocals. Please note that the values of U, V, and their respective reciprocals have negative signs according to the sign conventions. It's time for calculations now. The calculations are to be made with the help of graphs. So we plot a graph between U and V first. U is taken along negative x-axis, while V along negative y-axis. Plot the points after choosing an appropriate scale. X-axis 1 centimeter is equal to 10 centimeters of U. Y-axis, 1 centimeter is equal to 10 centimeter of V. After joining all the points with a free hand, the graph is a hyperbola curve. To find the focal length, we will draw a line OA bisecting the angle X dash OY dash and intersecting the graph at point A. The coordinates of this point are -2f, -2f. Thus, measure the distance AC is equal to AB is equal to -2f. Half of any of these distances give the focal length. Thus, AB upon 2 equal to AC upon 2 equal to -30 divided by 2 equal to -15 centimeter is the focal length of the given mirror here. Next, we plot a graph between 1 by U centimeter inverse versus 1 by V centimeter inverse. Do not forget to decide an apt scale. X-axis, 1 centimeter is equal to 0.01 centimeter inverse of 1 by U. Y-axis, 1 centimeter is equal to 0.01 centimeter inverse of 1 by V. Mark the corresponding points. Joining them gives a straight line intersecting the axis in points B and C respectively. We calculate the focal length for both the interceptions one at a time. F1 is equal to 1 upon AB equal to -1 upon 0.067, which is equal to -14.93 centimeter for the given case. Similarly, F2 is equal to 1 upon AC equal to -1 upon 0.067, which is equal to -14.93 centimeter. Finally, F is the mean of these two values of F, that is equal to F1 plus F2 divided by 2 equal to -14.93 centimeter. Then this is how we present the result. The focal length of the given concave mirror are determined from U V upon S V graph is equal to -15 centimeter. 1 by U versus 1 by V graph is equal to -14.93 centimeter. Since it is also an experiment related to optical bench and uprights, the precautions as well as the possible sources of error that can occur here are just the same as you learned in the first experiment of today.
So students, I will now want you to get introduced to some questions for Viva related to the two experiments taught today. The first question is, what is the value of radius of curvature of a plane mirror? The answer is infinity. The next question is, how will you distinguish between the two given spherical mirrors as concave or convex? The answer, take one of the two mirrors in your hand and see your face in it. If the image of the face is smaller in size for all positions of the mirror, then it is a convex mirror, otherwise concave. The next question, what is meant by parallax? The answer, the relative or apparent shift between the two objects placed at different distances from the eye. When the eye is moved sideways is called parallax. आस है कि तुसीं आज दसे गए दोनों एक्सपेरिमेंट्स का पूरा लाभ लिया होना है ਅਤੇ ਨਾਲ ਹੀ ਇਹਨਾਂ ਦਾ ਮਜ਼ਾ ਵੀ ਲਿਆ ਹੋਣਾ ਹੈ। ਅੱਜ ਦੇ ਲੈਸਨ ਤੇ ਧਿਆਨ ਦੇਣ ਲਈ ਤੁਹਾਡਾ ਸਾਰਿਆਂ ਦਾ ਧੰਨਵਾਦ। ਅਗਲੀ ਕਲਾਸ ਵਿੱਚ ਹੋਰ ਨਵੇਂ ਵਿਸ਼ੇ ਨਾਲ ਫਿਰ ਮਿਲਾਂਗੇ।